Okay, so let's see if we have e to the bar or exponential function, how we can solve this question. So let's talk about question 12. Okay, so let's solve question 12. Okay, so question 12. Now for the domain, this is equal to 1 over e to the bar x squared, which means if we would like to find the domain, it will be all real numbers except the zeros of the denominator. Now, once you take the denominator, make it equal to 0, that means you have to take ln for both sides to get rid of the e, and we cannot take the ln for 0. So in here, undefined value, so it will be rejected. So directly the domain, since there's no 0 for the denominator, I will say it's r from minus infinity to infinity. Okay, now f prime directly. So in here, this is the derivative of the exponential function is the same exponential function multiplied by the derivative of the exponent. So x squared, the derivative of the exponent is equal to minus 2x. That's it. Okay, now let's make the derivative equal to 0 as usual. So in here, minus 2x e to the power minus x squared equals 0. So this is going to give me x equal to 0. And for this, once you make it e to the power minus x squared equal to 0, the same thing, I have to take ln for both sides. So there is no ln for the 0 undefined value, so it's rejected. For x equal to 0, it's accepted. So the critical number over here is the 0 only. Okay, now find the second derivative. Okay, now for the second derivative, it's a product of two functions. The derivative of the first one, which is minus 2x, the derivative of minus 2x is minus 2 multiplied by the second one, minus x squared. Okay, then plus, now we will write the first one again, minus 2x multiplied by the derivative of the second one, e to the power minus x squared multiplied by minus 2x. Let's just simplify it more. So minus 2 e to the power minus x squared. This is going to be minus 2 multiplied by minus 2. This is plus 4 x times x is x squared. Then e to the power minus x squared. Actually, we can take minus 2 e to the power x squared as a greatest common factor. So that will give me minus 2 e to the power x squared or minus x squared. Okay, multiplied by 1 from here plus 2, because we took the 2 or minus 2. Sorry, in here it's not a plus, it's minus. So let's erase this. So in here it's minus because we took minus 2. So in here 2, and after that we have x square only. Okay, now let's make this equal to 0. That will give me from this e to the power minus x square equals 0. This is going to be rejected. From this I will have x equal to positive negative 1 over square root of 2. Now all I have to do is just taking the number line. Okay, so I will put the values minus 1 over square root of 2, and this is 1 over square root of 2. Now I'll find the values. I'll substitute the values in f double prime. So let's go ahead and substitute these values. So in here, this is our calculator. So alpha, or for alpha I have minus 2, then alpha e to the power minus x square Okay, then I have plus, then minus 2, or let's write the one downward, which is a plus 4 x square. So alpha x square. Okay, I'm writing this downward. Multiplied by e to the power minus x square again. Okay, so let's substitute a value less than minus 1 over. Now for the 1 over square root of 2, this is equal to 0 0.7, almost 0.707, something like this. So I'll substitute a value greater than 1 over square root of 2. So calc at, let's say, 1. Okay, this is positive. Let's substitute a value between them. Calc at 0. This is negative. Let's substitute a value less than. So minus 5. So it's positive. Positive, negative, positive. So that's it. I have over here, I have positive. So that's it. Positive, negative, positive. So this is concave up, this is concave down, and this is concave up. So now I will write down concave up, concave down. This is from minus infinity to 1 over minus 1 over square root of 2, union with from 1 over square root of 2 to infinity. And the second one, or concave down, it will be from minus 1 over square root of 2 to 1 over square root of 2. Okay, that's it. Then the inflection point, we have inflection points, which is at minus 1 over square root of 2 and f of minus 1 over square root of 2. The second one is 1 over square root of 2 and f of 1 over square root of 2. That's it. Okay, now just for finding the local points, I'll find them over here. So I'll find f w prime of the critical number. The only critical number we have is 0. So I'll substitute the 0 in the second derivative. So in here, e to the power 0. So let's see. Let's keep this. So let's substitute the 0. Calculate at 0. This is equal to minus 2, which means if it's minus 2, so this is minus 2. That means it's local max, since it's less than 0. That's it. And now we have finished our question. So we have found the concave up, concave down intervals and the local points using the second derivative test. So next, inshallah, we will solve a question which is rational function. Okay, then خلاص, we will move to the next topic. If you have any question, you can ask me directly or send it to me and I will help you solving the question.